Hey, welcome back to the lecture. So I just created the template and I have got it.c, main.c and msp.c, and in it.c actually there is only one IRQ handler, and in the main.c I have HSC initialization, GPIO init, UART init. Okay, great. And in the msp.c we have MSP init and UART init. Now let's go to MSP init and let's write a function can init or can1 init. So let me just mention the prototype of that here. All right, and we have to have can handle, right? So as you know, every peripheral will have its own handle, so can underscore handle. So let's make it as can1. All right, so now let's go to the can handle and let's see what are the member elements of that structure. So here it is. The first one is instance, you already know this, and next is init. Okay, so init, so this structure is actually used to initialize can parameters. Now let's get into this, and here it is. So this is a structure, so which is actually used to let me maximize this. So this is a structure which is used to initialize can parameters, and it has various member elements. So the first one is prescaler. This actually specifies us the length of a time quantum, okay, or time quanta. So that I will explain in a moment, don't worry. And next one is mode. So mode, you already know. What is the mode we want to use in this exercise? Loopback mode. So for example, if you search this reference, here it is: normal mode, loopback mode, silent mode, and silent mode plus loopback mode. Okay, so normal mode means a normal operation on the CAN bus. We will be using loopback mode in this application, and after that you can even try with silent and silent loopback. Okay, so I don't want to cover that because that is exactly same as loopback. Okay, so just you have to change the name. Normal mode is for normal communication that we'll use in our later exercises. Now let's go back. Now next is synchronization jump width. I will tell you about these configuration in a moment, don't worry. So these are called as can bit timings. Okay, so bit timings related settings. Now time triggered mode, we will not be using this time triggered mode, so I think this will be disabled by default. Okay, so you have to use either enable or disable here, so let's not worry about this. Now auto bus off, so this you can either enable or disable. Bus off means node which is going off the bus if it is causing too many errors, okay, or transmit error or receive error. After that, auto retransmission, auto wake up, and receive FIFO locked. So all these are, if you just check here, either enable or disable, and all those settings have default. So some are actually by default enabled or some are by default disabled. The one important thing is auto retransmission. So as I said, if a transmitter detects no ACK, then it would retransmit the message, right? So that would happen only if you enable the auto retransmission. Couple of other settings we can explore as we make a progress. So because some are related to FIFOs and all, because we have not yet explored those things. The important thing is these bit timings, and I will explain you that in a moment, don't worry. So these are actually related to, that is this one, and this one, as well as this one. They actually determine can bit timings and bit rate. Okay, so that's why those things has to be configured properly. And these settings are actually used to configure the TX engine or the RX engine. Great. So now let's go back to main.c and let's implement this function. All right, now let's come here and let me implement here. Before implementing, as I said, I'm going to explain these settings. So now let's go to this website. Okay, so I have also given this link in the resource section. So this is actually to explore the can bit time calculation. And if you just take a look into this figure, so this is actually 1 bit. so far you have been seeing this diagram, isn't it? So this is actually a bit, isn't it? So this can be a dominant bit or this can be a recessive bit, right? Now what is the width of that bit? So that is depending upon the clock frequency we use. So just take a look into this slide. That 1 bit duration, okay, of CAN protocol or CAN message, whatever, that 1 bit is divided into 4 segments. Okay, so each bit on the CAN bus is, for timing purposes, divided into 4 segments. So 1, 2, 3, 4. Okay, so the first segment is called as synchronization segment, second one is propagation segment, third one is phase segment 1, and the fourth one is phase segment 2. So a bit is collection of all these segments. So all these segments are required for transmission as well as reception purposes, and these segments are actually decided by the specification. Now these are required for the correct operation of the CAN bus, I mean correct transmission as well as for reception. Now width of these individual segments have to be adjusted properly to get desired bitrate on the CAN bus, right? So width of each segment is mentioned in terms of time quantas. Okay, so what is time quanta? Time quanta is the smallest time unit for all configuration values. Time quanta is the smallest time unit. Okay, now how to determine time quanta? So what is the width of one time quanta? So that you have to calculate based on what is the clock frequency you supply to the CAN peripheral. So for example, let's go to our application. So here what we are doing is we are using HSC in order to generate a PLL output clock of 50 megahertz, right? So basically, so if you just look into this diagram, so I'm using HSC and 50 megahertz, so H clock is 50 megahertz, and I cannot use the APB1 prescaler as 1 here because that would exceed the limit, so I have to use 2. So basically we are supplying 25 megahertz to the APB1 bus, isn't it? So our CAN 1 is actually hanging on APB1 bus. So if you want to take a look, you can check in the reference manual. So here it is. CAN 1 is actually hanging on APB1 bus. So we are actually supplying 25 megahertz to the APB bus, and if you just check this init structure, so it has a prescaler. So CAN comes with its own prescaler, so by using that you can slow down the clock. So let's say if you use prescaler as 1, then 25 megahertz will be supplied to the CAN peripheral, or you can increase this value in order to slow down that. Okay, so if the APB1 clock is 25 megahertz and prescaler is equal to 1, then what would be the time quanta? So 0.04 microseconds, right? So that is one time quanta, and these segments has to be mentioned in terms of number of time quantas. Synchronization segment is always one time quanta, and propagation segment may be 5. So phase segment may be, let's say, 10. So phase segment 2 may be 8, etc. So a bit is actually collection of all the segments or number of time quantas. So that's why it means as you increase the width of a bit, what happens? Your bit rate comes down, isn't it? Right? Because you are using more time in order to transmit one bit. And if you just shrink this bit time, then you will get higher bit rate. But shrinking just like that is not good. Most of the time you will face issues. Okay, so for example, when you increase the distance of a CAN bus, so if a signal has to propagate for a long distance, in that cases you may face issues if you just shrink the bit timing just like that. Okay, so you have to properly calculate it. So for that purpose, so this calculator is given. So here you just select your CAN controller. Let's say in our case ST Microelectronics BX CAN, and clock rate we know that is 25 megahertz, right? So at least in our application. Now let's request table, and here it is. So it is suggesting you some values. Here it is saying that you cannot achieve 1 Mbps, okay, by using this configuration. So if you increase it to 50 megahertz, let's see what happens. So here you can see you can achieve 1 MB here, okay, 1 megabit per second. So if you use this configuration, that means you have to use the prescaler as 5 and number of time quanta will be 10. So out of that, 8 will be given to segment 1, that is propagation segment and phase segment 1. So that means propagation segment and phase segment will have 8, and 1 is given to segment 2, okay, 1 is given to segment 2. So that means 8 plus 1 9, and 1, so synchronization segment will always 1 time quanta, so totally 10. But what this table recommends is that use something which is highlighted by the yellow line. So here you can see that the yellow background rows are settings with an bit time consisting of 16 time quanta. So that means if your 1 bit is 16 time quantas, then it will work properly. So that's what they mean. So that means basically what they are saying is if your 1 bit is collection of 16 time quantas, then it is always recommended and your CAN application will work properly. It's just a recommendation, as it says yellow background rows are settings with an bit time consisting of 16 time quantas. At the time this tool was first developed, this seems to be the best value. Basically they are saying 16 is a good number to use for a bit, but with this bit width, so maximum you can achieve is 125 kilobit per second, okay. And if you want to drive at 1 MB, you can do that, okay, but the thing is you have to reduce the time quantas and you have to test this whether it works on your application or not. Great. So but in our case the clock rate is 25, isn't it? So here in this table, let's run our CAN at 500 kbps and let's see it works or not, okay. So basically you have to use the prescaler as 5, that is this one, and mode is loopback, and then you have to mention this, okay, number of time quanta is 10, segment 1, propagation segment, phase segment. So this is always 1, remember. I think this field can be located at this reference. Let's see. So basically you can use it as 1 time quanta. All right, and after that we got this one. Now this one, segment 1. So segment 1, let's see what are the recommendations here. Now segment 1 you can use 1 time quanta, 2 time quanta, up to 16 time quanta. So basically it is saying use 8 time quantas for 500 kbps, okay. All right, so let's use that, and we'll use segment 2 as 1, okay. Let's see it works or not. I'm not sure whether it works or not, okay. We have to try it, otherwise we have to go for lesser bit rates, but we'll test this. So just go through this web page and I'll see you in the next lecture.